In this next question, we're going to solve for the variable x, where x plus 7 over x plus 1 plus 4 over x minus 3 equals 6x plus 7 over x squared minus 2x minus 3. Well, the first thing we want to do at this stage is factor our factor our denominators. X plus 1 simply factors to x plus 1, and x minus 3 simply factors to x minus 3. X squared minus 2x minus 3 factors to x plus 1 times x minus 3. And so now we have to consider each of our two distinct factors and consider each of them individually. Let's consider the factor of x plus 1. We have 1 in the first denominator, none in the second, and 1 in the third. Given a choice between 1 or 0 or 1, we take the greatest possible option, which is 1. So we will have one factor of x plus 1 in our lowest common denominator. Looking at the x minus 3 option, we see that we have none in the first denominator, 1 in the second, and 1 in the third. So we are going to have 1 in our lowest common denominator. So our lowest common denominator will have one factor of x plus 1 and one factor of x minus 3. And there it is. We have to also consider our restrictions. Our restrictions will be x cannot equal negative 1 or x cannot equal 3. Because we set each of those factors equal to 0 and then isolate the x. And we cannot equal those values. Okay, so if we get to the end of the question and we have a solution for x that matches either one of these values, then that solution will be invalid. Well, we then proceed with the question. We set each of these fractions, or rational expressions I should say, over the new lowest common denominator. And then we ask ourselves, well, what did we multiply the original denominator of x plus 1 by to get x plus 1 x minus 3? And the answer is we multiplied it by x minus 3. So we're going to multiply our numerator by the same amount. So we're going to have x plus 7 times x minus 3. Our second denominator started at x minus 3, and now it's x plus 1 x minus 3. So what did we multiply our denominator by? Simply a factor of x plus 1. So let's multiply our numerator by the same factor. We're going to have 4 times x plus 1 over x plus 1 times x minus 3. And finally, our first denominator was our denominator at the end, on the right-hand side of the equal sign, was x squared minus 2x minus 3. Well, what did we multiply that by to get x plus 1 x minus 3? The answer is we multiplied it by 1. It stayed the same. So our numerator will stay the same as well, 6x plus 7. At this point, if you notice, we have the three terms and every one has the same denominator. We can clear the denominators and simply solve for what's in red. And the reason we can do that is because we're multiplying each of the rational expressions by x plus 1 x minus 3. And that wipes them out of the denominator, so to speak. And you might say, but you can't multiply by something that equals 0. And you're right, but that's why we stated our restrictions up here. So, to put it more succinctly, we clear the denominators. This actually means that we will multiply each term by x plus 1 x minus 3, which is a valid next step as long as we keep the restrictions in mind that x cannot equal negative 1 or 3. So go back to the red and let's solve it, ignoring everything else. So we restate x plus 7 x minus 3 plus 4 times x plus 1 equals 6x plus 7, right there. Then we expand the left-hand side. We collect like terms and isolate and get a 0 on the right-hand side, and we end up with a quadratic of x squared plus 2x minus 24 equals 0. We then can factor that to x plus 6 times x minus 4 equals 0. Solving that will give us x equals negative 6 or x equals 4. We have to compare that with our restrictions. Our restrictions told us that x could not equal negative 1 or 3. Our answer is that x equals negative 6 or 4. Neither of these is restricted. So since neither of these solutions conflicts with a restriction on x, therefore x equals negative 6 or x equals 4.